Hello, thank you for watching this video. So on this video, we'll be doing question 7 of May, June 2024, question paper mathematics paper 2. The topic is 3D application of trigonometry. So it's application of trigonometry. So I have this triangle here, I have this 3D diagram here, right? No problem. 7.1 reads as follow. In the diagram, triangle ABC is drawn. AD is drawn such that AD is perpendicular to BC. Right? So, this is triangle ABC, right? So, we have AD here. You can see this brown vertical line. So, they're saying AD is drawn such that it's perpendicular to BC. You can see there is 90 degrees there. Right? That's what we're given. So, we're given triangle ABC and that have this height here. This perpendicular distance AD. That's what you're told. No problem. Okay, so now 7.1.1. They're saying use the diagram above to determine AD in terms of sine angle B. So they're saying we should use this diagram here to determine AD in terms of angle B, right? So where's angle B? Angle B is here. And what do we want? We want AD. So in triangle ABD, this triangle here, this one joined by AD here. You can see that this triangle is a right angle triangle, ADB. ADB is a right angle triangle. So we can apply our trig ratios nicely there. So if you want the opposite, right? We have the opposite. If you want to use sine B, right? If you want to express AD in terms of sine B, so this sine B of yours and sine of angle B will be equal to opposite, which is AD, over the hypotenuse side, which is that side over there, which is AB. Right? So we want AD, which is this height here, in terms of sine B. So all we have to do now is just to cross multiply. This is over 1, this times that. That's AD is equal to, this times this, AB sine B. So we have expressed AD here in terms of sine B. So your AD is equal to AB sine B, or sine angle B. We're done with that one. So now we're doing 7.1.2. They are saying, hence prove that the area of triangle ABC is equal to half times BC times AB sine angle B. They are saying 7.1.2. This is 7.1.2. They are saying prove that the area of triangle ABC is equal to half what? BC times AB times sine B. That's what they want us to find. So, if you want to try calculate the area of what? Of triangle A, B, C. The area is equal to half base times the perpendicular height, right? So half our base is what? Half our base is BC, right? Times the perpendicular height. What is the perpendicular height? Perpendicular height is AD times AD over there. So, area of triangle ABC is equal to half of BC times AD. But you found that your AD is equal to this. So, for AD you put AB sine angle B. And you have shown what they wanted you to prove. Prove that. So, here's the area for your triangle ABC. It's given by this. And we're done here. We move on to 7.2. So, what are they saying in 7.2? They are saying, in the diagram, points B, C, and D lie on the same horizontal plane. Angle D between AD and DB is equal to angle C, the angle between AC and CB. They are both equal to alpha. And they are saying that angle D, the angle between CD and DB is equal to theta, and DC is equal to K units. They also went on to say that BD is equal to BC. So what they're saying to you, that this angle here is equal to this angle over here. Right? What else? And both of them are alpha. No problem. What else are they saying? They're saying that this angle here is equal to theta. And this triangle, DBC, forms the base of this triangle. This shaded area forms the floor of this triangle. Right? Because they're saying that B, C, and D lie on the same horizontal plane. So B, C, and D are all on the same horizontal surface. So they're all on the same horizontal surface. B, C, and D. Right? They're telling me that this angle of elevation is equal to this angle of elevation here. Right? And then they went on to say that this one is equal to theta, and this side BC is equal to BD. So that side is equal to this side. So what you can do is, maybe what I like doing myself, I always just try to look at the number of triangles that I can see here. If you're looking at this, I see 1, 2, 3, 4 triangles. I see 4 triangles. 1, this is number 2, this is number 3, the one on the base. So this is the first triangle, 1, this is the second triangle, 2, and this is the third triangle, 3. And the red one is the fourth one that I see. So I will draw the triangle that I see. So here is the first one. This one here, 1. Here is 1. This is 90 degrees, of course. Here is the second one. This is triangle number 2. This is triangle number 2. And then there's one at the base here. So here is one at the base. The one at the base is triangle number 3. Then there's triangle number 4. Triangle number 4 is this face here, the big one. Right? I'll just draw it on the side like this. The big one. So this is A for the big triangle. Triangle number 4, the big one. This will be, no, maybe this is not the right spot for this big triangle. Maybe let me draw it down here. But I won't need it anyway. Maybe I can just leave it and work with these. So I have A, I have C here, which is C for this triangle, for triangle number 2, and also C for this. This is, both of these are C's. And this is D. And this one here is B. We have B here. So we have that this is equal to what? Equal to theta. And this is equal to alpha, we're told. And this is equal to alpha as well. Then, this is 90 degrees, of course, because you can see it over there. And what else do we have? We're told that this side is equal to this side. But this side is the same as this one, is the same as that one. So this is your D for all of those things. So if you're looking at this, you're looking at this triangle separately, all those two triangles. This is this one, this is this one, and this is that one, the base. This one here. Here is it here. So I like to carve them like that so that I can see them easily. No problem. What are they saying? 7.2.1. A 7.2.1. They are saying prove that AD is equal to AC. What are they saying? They say prove AD is equal to AC. So they're saying prove that this is equal to that. That's what they wanted to prove. How can we prove this? So AD is our hypotenuse here. So we can use Pythagoras theorem, right? In triangle. In triangle, what? ABD. In triangle ABD, we can say the hypotenuse, which is AD. We can say AD squared is equal to what? BD squared plus AB squared. What is this? This is Pythagoras, right? No problem. If AD is given by this on this triangle here, not a problem. So in the second triangle, which is ABC, in triangle ABC, you can find your hypotenuse, which you're trying to prove, because I defined the hypotenuse here, which is AD, to be this. Now I'm defining the hypotenuse to be of the second triangle, triangle number 2. So in triangle ABC, I can say now my hypotenuse there, can use Pythagoras again, can say it's AC squared is equal to BC squared, which is this side squared, plus AB squared. Right? No problem. So we have defined AC to be this, and we defined AB to be that. AD, the square of AD. We define the square of AD to be this. Now we define the square of AC to be this. Right? No problem. What do? We say, okay, we're told here that this length DB is equal to this length BC. We're given this information that your BD is equal to BC. So this length BD is equal to this one. So, which means if you're looking at these things of yours on this definition of the square of AD, and you're looking at the definition of the square of AC, you know that BD, this part, is equal to this part. Right? These two are equal, this and this. So, if you can write now your AD squared is equal to what? BC squared. Right? What? AD squared is equal to, I'm writing this, BD squared plus AB squared. And the second one, you can say your AC squared is equal to BC squared plus what? Plus AB squared. Right? No problem. What do? So, this is equal to this because you were given that these two are equal. So, your BC is equal to your BD. Right? Your BC is equal to your BD. This was given information on your statement. So we know that these two are equal. This side is equal to this side, this side is equal to this side, because this and this are the same side, this and this are the same side. So what you have here, you have your AD squared equal to what? BD squared plus AB squared, right? Which is this. And your AC squared is equal to your BC squared, but your BC squared is equal to BD squared. So you can just say your BD squared because these two are equal. So instead of BC, just place BD plus AB squared. So this plus this is the same as this and this. So this one is equal to this. So this is equal to this. So this is equal to this. Therefore, your AD squared is equal to your AC squared. Therefore, your AD is equal to your AC, which is what we wanted to prove. And we're done here. We're done with this question. So, I'm going to clean this side. I think we might need more space to do 7.2.2. So I'm going to clean this side because I think we might need more space. Okay, so now we're doing 7.2.2. They're saying that prove that BD is equal to K over 2 cos theta. That's what they want us to prove. They want us to prove that BD is equal to K over 2 cos theta. So where is BD? BD is this distance here. Right? That is BD. It's this distance here. Or maybe you can say it's this distance over here. So they want us to prove that this distance is equal to this. So what do we have? We have this side here. Right? We're told that this side is equal to this side here. And we have this side to be K, we're given there. So we want to prove that this side BD is equal to this. So we can try to use the cosine rule, right? Because we have something upon all sides. We know that this is equal to this, and this is on its own here. So we have this is equal to that, and we have k, and we have an angle there, right? No problem. So if we're looking at the base triangle on this triangle here, it looks like this. We have theta here, we have D, we have B, we have C. We have this is K, you know that this is equal to that, right? So we're told that it was given that BD is equal to BC, right? This was given. So we want to find BD here. So what do? We say, okay. Okay, we can try to use the cosine rule. So the cosine rule, this is small d, this is small c, and this is small b. So if you want to use your cosine rule, because we have this angle here, right? So you express it in terms of that side there, d. So it will be d squared is equal to b squared plus c squared minus 2bc cosine of angle d. This is how it will look like if you're using the cosine rule. What is your d? Your d is equal to bc squared is equal to your b squared. What is your b squared? Your b squared is this length here, which is what? Which is k squared. Plus c squared. What is c? The c is b d squared minus 2 times what? 2 times b. What is your b again? Your b is equal to k. What is your bd? Again, your bd is bd, which is what you're trying to find. Cosine of theta. That's what you have. No problem. So, because you're trying to find bd, right? So this and this, they're equal because the square of bc and bd are equal. So the square of bc and square of bd should be equal. When you are here, we are given that your bd is equal to bc, right? And you're trying to find bd. Express this bc in terms of bd because that is what we're trying to find in the first place, right? So you can say your bd squared is equal to your k squared plus your bd squared minus 2k bd cosine of theta, right? So let's transpose these to this side, right? This and this. So we have the bd squared minus k squared minus bd squared, which is this one, is equal to negative 2k bd cosine theta. So this and this go away. So you're left with what? Negative k squared is equal to negative 2k bd cosine of theta. Right? So when you're here, you can divide by negative both sides and this become positive. Right? So what you're left with? You're left with this, which is your 2 cosine. So it's 2k bd cosine of theta is equal to k squared. Then you divide by 2k, because you want to get rid of 2, you want to get rid of k, cosine of theta. Both sides 2, because you want to remove this and that, so that you're left with bd alone. 2k cosine of theta. So the 2 go away, the k go away, the cosine go away, so left with bd this side is equal to your k squared is k times k, right? So 1k go away, so you're left with k over 2 cosine of theta. So that is your bd, which is what they wanted you to propose it. So we're done with this one. So we'll go to the last one, 7.2.3. What are they saying in 7.2.3? What are they saying? They are saying, determine the area of triangle BCD in terms of K and a single trigonometric ratio of theta. Right? So they want us to find the area. They want us to find the area of what? Of triangle BCD in terms of K and a single trigonometric ratio. So where is triangle BCD? Triangle BCD is this one. The same one that we have here. Right? No problem. So let me redraw it again. So here is it. So we have that this is B, this is D, this is C, right? So what you have that this is equal to this side, right? And this is K, and this side here is BD. And just find that BD is equal to K over 2 cosine of theta. So if you want the area of triangle BCD, of BCD, area of triangle BCD is equal to what? It's equal to half of DC times BD times the sine of the included angle, which is sine angle D. The area of triangle BCD is equal to half of what? Of DC. What is your DC? Your DC is equal to K, so half of K times BD. What is your BD? BD, we just calculated it here, right? So here's BD, which is that side. So BD is K over 2 cos theta, right? Times sine angle D. What is your angle D? Your angle D is theta. So your area for triangle BCD is equal to half of what? K times sine. So you have K squared sine theta, right? All over 2 cos theta. That's what we have. Right? No problem. Therefore, your area for triangle BCD is equal to 1 times K squared sine theta. So that is K squared sine theta all over 2 times 2 cos theta. That's 4 cos theta. And this is tan, right? So sine of theta and cosine of theta. Sine theta over cosine of theta, or sine theta divided by cosine of theta. That's a tangent of theta. So your area for triangle BCD is equal to K squared tangent of theta all over 4. So this should be our area for triangle BCD. And I hope it does make sense to you as it does to me. Thank you for watching. Cheers.